Welcome. I'm Mark Turner, the External Relations Director of SRM 360. Welcome to our live discussion on sea ice and solar geoengineering. For those of you who haven't joined us before, our goal is to support an informed discussion about sunlight reflection methods, also known as solar radiation modification, or SRM, and how these interventions might affect a variety of climate impacts in a warming world. We, as SRM 360, don't take a position on whether SRM should be deployed or not. However, we do support its research and broad-based discussions on the way forward. Our goal is to present the science and the issues and forms people can use so they and their audiences can come to their own views and contribute to decisions. So thank you again for coming. Really hope you enjoy the discussion. Please ask any questions that you have in the little Q&A chat feature at the bottom, which you can see at the bottom of the screen. And we will direct some questions to the panelists both halfway through and at the end of the session. I'll now turn over to Pete, our editorial director.
Thanks, Mark. Let me just share screen quickly. Excellent, that should be coming through. So today we're joined by three experts to discuss the rapidly changing Arctic and whether solar geoengineering or other interventions could be justified to address this challenge. There they are. The key indicator of that change that we'll focus on in this discussion is the decline in sea ice. Here you can see the annual minimum sea ice coverage that happens in September each year and how it's evolved over time from the 80s through to here now we're in the mid-2000s, 2010s, and it's getting quite a lot smaller than it used to be. Now, in the next slide, I'll show you that in context. So rising temperatures are driving the long-term decline in the minimum sea ice extent, though other factors matter too. 2012 saw the lowest sea ice extent on record due to both exceptional heat, but also prevailing winds and a powerful storm which drove ice out of the Arctic basin. The rapid changes we're seeing at the poles have motivated a growing number of researchers to propose, study, and in some cases develop potential interventions that they hope could limit these changes. I'll just run through a couple of those briefly. There are solar geoengineering ideas which could cool the entire region. For example, stratospheric aerosol injection, or SAI, would create a persistent layer of reflective particles in the upper atmosphere. This would reflect light and cool the planet, and that would offset many of the impacts of climate change, not all, but crucially, it would reduce the melting of ice, which is having such an impact at the poles. There's also a whole set of more local interventions which could address particular changes at the poles. For example, sea ice thickening is a proposal that's being studied to spray seawater onto the surface of sea ice in winter in the hopes that that will thicken the ice so that more of it will survive through the summer. But this work is controversial. And a recent study authored by 42 polar researchers claims that none of the polar geoengineering interventions they assessed could help, and they could, in fact, harm the Arctic. They concluded that further research into the topic would be a waste of resources and would distract from the crucial task of cutting emissions. Before I introduce our panel, I'd like to pose a question inspired by this recent paper. So, Carrie, if you could pop our poll up. Oh, well, I need to stop sharing screen. Oh no, here we are. You can hopefully you can all see this. So, is further research into solar geoengineering and other polar interventions A, a waste of resources, B, fine but not really a priority, C, important and should be given higher priority, or D, urgently needed? So I'll give you a few seconds here to fill this in. I can't see how many people have filled it in. But I think once enough have, Kerry will close the poll and hopefully we'll see some initial answers. And we'll revisit this same question at the end to see if there's been any movement after our discussion. So we're going to see some answers. Maybe. There we go. All right. Well, I see our audience is skewed heavily towards the urgently needed and higher priority end of the spectrum. But we still got a little bit of not that important and a waste of resources. So great, we'll see how that shifts over the course of our discussion. Great. Now, I'd like to introduce our three panelists. We have John Moore, a research professor at the University of Lapland and glaciologist leading the University of the Arctic's Frozen Arctic Conservation Network. We have Julius Lindy, project advisor at the Sami Council, leading Indigenous-driven assessments of Arctic climate interventions. And we have Cecilia Bitts, professor at the University of Washington, specializing in sea ice, polar climate change, and Arctic climate prediction. So let me just close my, stop sharing screen here. Oops. There it is. So, Cecilia, let me just find my questions again. Sorry, I'm juggling screens here. So, I showed the decline in sea ice that we've seen in recent years, but can you give us the basics? What is sea ice and why does it matter?
Sea ice is frozen seawater, and that makes it distinct from snow and ice sheet. Uh, it is very important to the climate system because it covers the ocean and insulates it from the atmosphere, so the atmosphere can become much colder in the presence of sea ice in winter. It's very reflective compared to the ocean, so it kind of cools the planet year round. And in summertime, the surface is not able to go above the freezing point.
Great. And I think, let me just, I've got one more slide and then I'll quit messing around with my screen. Because I think sea ice is often mixed up with the other forms of ice that we have around the planet. So here's this little cartoon illustration. Can you just explain the distinctions between sea ice and some of these other forms of ice?
Sure. Sea ice is about as thick as a person is tall, though when it's deformed through its motion field, it can become thicker, maybe, the height of a house. But you can see at least the iceberg there is very, very thick compared to it. And the ice sheet also, and the shelves from the ice sheet that spill onto the ocean are also freshwater ice, and they are relatively thick too.
Yeah. And so I think one thing people often get mixed up about is sea ice, as it melts, it has lots of impacts, but it doesn't affect sea level, right?
That's correct. It's already floating in the ocean, and so it displaces the mass of water that it has equivalently. And so when it melts, it just fills in the hole. It's kind of like a glass of ice water. When the ice melts, it doesn't overflow your glass.
Yeah, and I guess so. Correct me if I'm wrong here, but glaciers and the ice caps are sort of small versions of the ice sheets. Is that fair?
Yes, that's exactly right.
Great. And then
And generally in mountains. Right?
yeah, and then permafrost. That's the other missing element here.
That's right. That's a frozen land. So it normally we think of it as water in the soil, but it could just be soil itself. It's
Yeah.
anything land, but that's frozen.
And am I right that one of the crucial things about permafrost is that because it's frozen, the carbon, the material, the biological material in there can't degrade, and then as it melts, that changes, and you can get a lot of carbon coming out.
Correct? Yes, it can release methane and other kinds of carbon gases. So it's certainly a concern for global warming because as it retreats, it can accelerate the greenhouse gas concentrations in the atmosphere that we think are causing global warming.
Excellent, thank you. All right, let's stop using my other screen now. Let me rearrange a little again. Okay. So, yeah, I guess one thing we saw that record minimum occur in 2012. Does that mean should we worry so much about the Arctic if it looked like it was retreating very quickly and since 2012 it hasn't declined as fast?
That's certainly true that it hasn't declined as fast. But I think in many ways it was ahead of its time, right? It really hit extreme lows in first time in 2007 and then again in 2012 that were very unexpected. I think it's also similar, to global warming, where we saw a slowdown in the warming between about 2000 and 2013. It's as if the sea ice is having its slowdown period now. But if you think about it, like global warming had an extreme warming then after the slowdown period. And I think that's entirely possible that we're kind of seeing this sleeping giant. So it could pop, down very rapidly now. We don't know. It's very hard to say. But there's just a lot of internal variability in the climate that is on top of the long-term global warming record. Um,
Yeah.
so it shouldn't give us, I think, a false sense of confidence that this is, gonna stay, steady for a while.
Okay, thanks. So, John, you've conducted field work at both poles for decades. How have the changes you've seen there affected your work? What's it looked like as over the years?
Well, yeah, it certainly has changed. I mean, the first time I went to Antarctica, we got stuck in the ship in the ice and had to abandon it because it was, in danger of being dragged onto rocks and sinking. These days, if you're going by ship to places, it tends to be easier because you've got less ice between you and where you want to go. But on the other hand, it can be very variable. The ice is sort of more disconnected, so you're likely to get crushes in different places as the wind changes. And well, it's definitely something that has very low inertia. It's something that can change within a year or two quite drastically, as we saw from those records.
So that's one thing, because I guess I've heard people talk about the loss of sea ice as something that's a tipping point. But I mean, if we picked up the sea ice and sort of tossed it off the planet, would the Earth change dramatically the next year, or would it all grow back quite quickly?
Well, I think it would change immediately when you don't have any ice there. You find things like the jet stream, which brings depressions across the Atlantic and into the Arctic, and that tends to be related to where the sea ice boundary is. And over the recent decades, there's been a lot more depressions making their way into the Arctic basin, the Arctic Ocean itself, bringing a lot more warm conditions, bringing a lot of even ice-free periods at Christmas time to the North Pole. So there would be an immediate albedo influence, but on the other hand, because it's this relatively thin layer, only a couple of meters thick, it wouldn't take an enormous amount to produce that again. It's not like trying to grow an ice sheet that's 1,000 meters thick. It is relatively sprightly in its responses.
Yeah, great. Well, Julius, what impacts have the changes we've seen in the Arctic already had on indigenous communities there?
Yeah, so regarding sea ice, Arctic indigenous communities certainly do, yeah, notice not only the loss of the sea ice, but also they also know that it's forming way later on in the season, and yeah, that it's becoming less and less stable, and yeah, also less predictable where it is stable, which of course makes it then more dangerous for them to for example for hunters to travel over it and yeah do hunting. So for the indigenous people who rely on sea ice in their livelihoods, they face greater risks of falling through the ice and or being stranded, or they may not even reach the places where they usually do their yeah, hunting, or where they have access to resources. So this is also a big matter of food security on the communities of the Arctic, where yeah, the species, some animal species also have their migration patterns disrupted. So it's incredibly. I'm not an. I should also specify I'm not an Inuit myself, but I'm a Northern Sami in Sapmi. But it is. I can tell you, it's very detrimental for the Inuit. Who rely on sea ice, and yeah, it sort of poses an existential threat to them since they're uh, since sea ice is so deeply ingrained within their identity and culture, and yeah, really their lives. So yeah.
Yeah. And to the Sami, what kind of impacts are we seeing as well?
Yeah, so as mentioned, or in Sapmi, we don't have much of sea ice in our fjords or coastal areas, so since yeah, we do get the warm streams from the Atlantic Oceans and coasts, but um, yeah, but we do see the same sort of degree or patterns of challenges in our own livelihoods and threats to our own security and safety of food as well. So climate change has already shown to alter the snow and ice conditions of the the land. So this is not a sea ice condition, but the ice on land,
Yeah.
and specifically pastoral lands that the reindeer graze on. Okay, so what has been happening more and more is frequently is that there has been more rain on snow events, so-called rain on snow events that lock the pasture away, the reindeer away from grazing. So the reindeer cannot break through these layers of ice to access food, which then forces our reindeer herders into some crises and either force them to move distances to get into better pastures, or they have to feed the reindeer straight up with emergency hay bays or something like that. So
So what's the problem with snow on ice or ice rain on snow? I mean, why does that matter for the reindeer?
Yeah, so that makes it so that the reindeer cannot access the grazing land, so that the food under that's under the snow cover or ice cover. So what happens is that you have rain on snow events, which makes the snow wet, and then there's usually a cold night following that, which freezes the snow that makes the the grazing ground inaccessible, so to speak. So, yeah, so that's one example within reindeer herding, I guess. But we also see other detrimental changes in other sources of sustenance, like salmon fishing or berry foraging and ptarmigan hunting in many different subtle ways, I would say.
What's a ptarmigan? I haven't heard of one of those before.
It's an Arctic bird. I actually struggled to translate or find the name in English. So I guess
that's okay.
grouse is it's very related to grouse, but I'm not sure if that's the right word in English. But Arctic ptarmigan is, I guess, the closest one. Yeah.
Sorry,
So it's sort of like a bird hunting.
Excellent. Okay, cool. I'm
A
getting
bird that is
distracted
popular
by
to
animal names. So Cecilia, we've seen the world warm roughly 1.5 Celsius so far. How much has the Arctic warmed, and what can we expect for the Arctic as the world might warm through 2 or 3 Celsius?
The Arctic warms roughly 3 times faster than the globe. It can be more than that. In fact, we've seen it be 4 times in the last 20, 30 years. So it is devastatingly more warming that's occurring in the Arctic because primarily of the sea ice loss amplifying the response. Sea ice is involved in several feedbacks that amplify global warming. So with that kind of warming, if it's 2 degrees globally, we'd expect something, 7, 8 degrees in the Arctic. The Arctic sea ice won't survive. In fact, it could disappear in 10 years. It's on the verge. And it's just at the end of summer, I want to emphasize, it won't be absent all year. But by the end of summer, when it's at its minimum, we'll see that minimum approach 0 pretty quickly here. That's been predicted for a long time, and we're close already. We've already lost more than half of the sea ice in summer. It's also thinned similar amount, about 50%. And we have excellent records of sea ice thickness from submarine data going back to the 50s.
Yeah. And so would you describe the loss of sea ice in summer as a tipping point? Is it that, things are okay, and then when you hit that crucial point, things are dramatically different? Or is it just sort of a sliding scale that you end up with more and more of the Arctic Ocean open more and more of the time? Like, how would you describe that dynamic as we get towards that point and then beyond it?
It's extremely rapid, is how I would describe it. That it's very sensitive, but the evidence isn't clear that there's a tipping point in the summer sea ice. However, in winter time sea ice there is, which is kind of ironic because we think of the big amplifying effects as being in summer, but it's because the big damping effects are in winter, and as we lose those, it can't recover. So we actually expect a tipping point in winter time.
Yeah, but I guess I'm thinking more in terms of maybe you could describe them in a bit more detail, the feedbacks that
Right.
as we lose the sea ice, how that impacts the rest of the world. I mean, I guess ice is very reflective. So could you just describe that as, as we lose more and more of the ice, what impacts that have?
Right. People have quantified just how much the Arctic cools the planet. So, currently we've added enough carbon dioxide to the atmosphere to cause a radiative forcing of about 1.5 or so watts per meter squared, with all the other additional forcings out of, in sun. And sea ice is about that same amount. It's If we lose it all, it would be a similar amount. So it's a big, amplifier globally. However, we, would expect the amount of forcing to be a little bit higher by the time we lose the sea ice. So it won't be equal, but it'll be, a competitor, right? So
Mm.
it is a factor that amplifies the global warming as well.
Yeah. John, looking a bit more broadly beyond sea ice, what other kind of changes could we expect across the Arctic, and how worried should we be about them? You're muted.
Of course, you've got the large amount of carbon stored in the permafrost, and that is going to be a worry. There's more carbon in the available in the permafrost should that thaw than humans have put in to the atmosphere. Lots to go, then it's kind of game over on emissions policies. And then you have the threats from sea level rise and ice sheet collapse. And those are tipping points in the sense that you can lose them and they'll be very difficult to get back.
And just on the permafrost, you say, that's it, the total amount in there rivals what we've already put into the atmosphere. Is it a case of, once temperatures rise above 0 Celsius, we get all that emitted, or is this something that will take hundreds and hundreds of years to decay? And what's the scale of that threat? I mean, you've given the kind of magnitude total, but
Yeah, it's the permafrost is not very thick, and we're talking about a few meters of the top 3 meters essentially. There's an average, the annual summer thaw goes down about a meter. So as that thaw gets deeper, more and more of it comes in. So it's you can imagine the boundary of permafrost moving northwards over time, and that would gradually release more and more permafrost as it has done. But one of the big uncertainties with permafrost is actually mapping it well enough. Very difficult to to just go and observe it because it's covered by forests and it's not clear just by looking that you've actually got permafrost underneath the ground. So everything's done by models so far, really. There's groundwork, but it's relatively patchy.
great. Well, let me just turn to Julius. Before we close out this part of the discussion, or open up questions, you've been very involved in a project led by the University of the Arctic, focused on interventions to help limit these impacts. Can you describe the overall effort? And we'll get into a bit more detail after the break.
Yeah, sure thing. So Sami Council has committed to be the sort of project lead on what is called what is now known as the U-Arctic Climate Interventions Project, the indigenous peoples assessment part of it. That's the part of the project that we're taking the lead on. So the whole U-Arctic Climate Interventions project, it has already had a first phase where 61 different ideas to slow down, halt, or reverse the effects of climate change in the Arctic have been identified. And now we're in the second phase where Sami Council is leading the indigenous peoples, Arctic indigenous peoples assessment of those interventions and eventually further interventions that are identified. So this is happening in parallel with other assessment efforts on the more technical side. Just last week we two assessment teams were launched in relation to atmosphere and sea ice, actually. So so we are sort of doing an independent Arctic indigenous peoples led assessment of it, along with other. So we're ideally going to work within the Arctic Council body to pull this off by collaborating with what is called the permanent participants, that is in the Arctic indigenous peoples organizations for indigenous peoples spanning across the Arctic. So it will. It's quite a big undertaking, many different ideas to work on, many different fields. So this is definitely something that we Sami Council would do alone. We're going to look into sea ice interventions. We're going to look into interventions related to glaciers and also atmosphere and solar radiation modification.
Excellent.
So
Great. Well, we'll get onto those in a bit more detail after the break, but
absolutely.
We're going to stop for a Q&A break in a minute. So put your questions in quickly on, I guess, the changing Arctic so far. We'll talk more about interventions in the second half. But just to, please, let's switch over to questions.
Let's start. And just a quick reminder, please, if you have questions, put them in the Q&A box rather than the chat. So let's just start. Perhaps I'll direct this one to Cecilia. Martin Murray asks, should we also be considering then the mass or volume of sea ice as well as the area and extent of sea ice?
I think so. And I mentioned just briefly that the volume of sea ice has decreased by almost as much as the sea ice concentration, the areal extent. So about 50%. And we know that very well. But people really can't walk and use sea ice when it's too thin. So if it's only a few tens of centimeters thick, it's kind of effectively useless, as a resource for people who use it for transportation and hunting. It also, protects the coastline with preventing coastal waves from crashing in and causing erosion. And when it's too thin, it just moves up with the waves. So we need enough to actually dampen the waves, to serve as a platform for humans. Many things.
And one more question for you, Cecilia, specifically directed towards you from Victor Yakala. He says some studies indicate that ice-free conditions could prevail up to 4 months, July to October, even at 2 degrees C of warming. Could these types of conditions really be expected in the 2040s if we hit 2 degrees C then?
That's a hard question for me to answer because there's quite a lot of uncertainty in those kinds of estimates. We rely heavily on climate models and they have a range. That is at the higher range, but yes, there are models that project 3 or 4 months of ice-free conditions by the mid-century from that kind of amount of warming. So very serious, but the majority would be less. It would be more like 1 month or 1.5. Yeah.
Thank you. I've got another question here from David Schechter, and I'll direct this towards John, though perhaps if Julius wants to jump in as well, please go ahead. Russia and others, says David, are very happy about Arctic warming as it gives them more access to hydrocarbons and for strategic military reasons. International shipping is also happy about it. So how can a real coalition be formed to fight it for environmental reasons?
Well, Russia's a strange thing. Every research proposal that goes through their funding agency has to supply a very detailed estimate of its carbon footprint. So at the national level, there is clearly a lot of concern, and whether that's just performative or whether that's a genuine concern is one thing. In the Arctic, there are more strategic concerns. As you say, minerals and hydrocarbons are very important there. And obviously, that's super important for Russia's finances and security. So the Arctic region in Russia has always been a special case, but perhaps Julius can expand on that.
Yeah, I guess I can mention that. I mean, I don't think it would necessarily when we're talking about the Russia, probably, yeah, maybe its government sees some benefits in regards to the abundance of hydrocarbons and so on. But I don't think the people's, for instance, Raipon in Arctic Council has always expressed that, yeah, climate change has is posing problems, or giving them a lot of problems too. So it's not like they would see it as necessarily as a benefit. So I'm not sure what their stance is on the abundance of hydrocarbons or the availability of it. But yeah, I guess I can look into that too.
Great. I see. I'll hand straight back to you in a second, Pete. And a number of the questions here, and I see in the chat, are related to climate interventions, which we're going to talk about in the second half. So we'll have time to discuss them later. There was just one question from Brian E. Collins from Carbon Pulse. I think it was with regard to permafrost melting. The question was, is that just for Arctic permafrosts, if we lose it all, equivalent to all human emissions so far? John, do you have an answer to that? Would you invite some more elaboration, or?
Well, fundamentally, most of the permafrost around the world is in the Arctic. There is, of course, some in the Tibetan Plateau, and the Antarctic area, of course, is covered by ice, or almost exclusively. So that's not directly exposed. So the sort of ticking bomb is the Arctic when it comes to greenhouse gases from the permafrost.
Thank you. And I'll hand back to you now, Pete. I'll just also remind, we'll definitely try to get to all the questions. And at the end, we'll also have a little extra time at the end of this for extra questions for those who want to can hang on. So thank you, Pete. Over to you.
Okay, so on to the controversial stuff. A couple of weeks ago, a widely publicized academic study was published in Frontiers of Science. It was titled Safeguarding the Polar Regions from Dangerous Geoengineering. And as you might guess from the title, it was quite critical. In fact, they concluded that no polar geoengineering interventions could help and that they would all be environmentally dangerous. This led them to argue that, and I quote, further research into these techniques would not be an effective use of limited time and resources. Now, I reached out to Professor Seeger, who led the study, as well as a couple of his colleagues. This was a little last minute, though, so but they were unavailable to join the call. If you want to hear more about their work from them, you can find a link to, I'm hoping Kerry can share a link to a panel discussion they had on this. I'm not quite sure if the recording is online, but I'm sure if you checked back there in a week or so, it would be. So yeah, you can check that link to find out what they said about their work, but we're going to be covering some of that now. Before I get into the specifics of their arguments, I'd like your reactions to what I think is the sort of the core argument of the piece, which is, if policymakers aren't distracted by polar geoengineering or other things, cutting emissions will prove sufficient for managing the risks of the polar regions face. Cecilia, what's your reaction to that view?
I wasn't as convinced by that, primarily because the current commitments are not very sufficient, right, to give us that really rapid decline we need to avoid 1.5 degrees Celsius warming. 2 degrees Celsius would be a little bit less challenging to avoid, but it's still very it's a lot of warming, and it's hard to even target that, right? We're struggling internationally, right? So I guess I thought it was kind of narrow-minded in that regard.
Yeah. John, Julius, anything to add to that kind of core argument?
Yeah, I mean, I would go further and I'd call it delusional. I think that the prospects of avoiding crossing 1.5 degrees when we're already at 1.5 degrees, how does that work apart from magical thinking? I don't see any pathway, and neither does the IPCC have a single scenario that keeps that 1.5 degrees from being crossed. Now, the duration of time that it crosses, we don't know. That depends on what the emissions are, but it will cross that threshold. And the best available knowledge says that drastically bad things happen, like the collapse of the Thwaites Glacier in Antarctica. And that impact on global sea levels will affect hundreds of millions of people. So I think it's all very great to say, yes, we can just rely on decarbonization, but I think it's time to look at any other tools that might help as well. We obviously need decarbonization, but it's not proceeded fast enough. We are where we are.
Julius?
Yeah, I'm not sure how yeah, we ourselves are gonna position in regards to this paper, but yeah, the what it does, what I can say about it is that yeah, it reminds me that of what we always have to do when we approach our own communities or member organizations of Sami Council on this subject of yeah, interventions in the Arctic. That yeah, we always get asked, for instance, well, why are we looking into this now? Aren't we still struggling with the source of the problem, that is the release of greenhouse gases, and the huge undertaking that is the green shift that has some big ramifications for our own communities in many bad ways. So it's I feel like yeah, this yeah, that this paper that it exists, it sort of like points to that the lack of proper communication that has been done by the field of climate intervention or geoengineering, that there's a lack of yeah, clarity on why we are doing this. We're probably not going to reach or stop before the threshold we want at 2 degrees. It's probably going to go over that. So we are sort of in a desperation to look into other measures that can help.
Yeah. So Cecilia, I guess they focused on 5 interventions, and I think perhaps rightly pointed to some of the technical challenges or limitations some of them face. And we're talking about sea ice, and I think 2 of the ideas, they might have bundled them together, are to do with sea ice. One is to thicken sea ice. I mentioned the idea of spraying seawater in winter, and the other is to increase the albedo of the ice by putting little reflective particles on top. Do these ideas have a hope of halting the kind of changes you've outlined for sea ice? Could this prevent sea ice hitting its minimum or getting to 0 in a warming world?
I think it's very possible locally to thicken sea ice, where if one would to put a pump that brings up seawater and floods the snow can refreeze and become very solid like sea ice. It has essentially the same good qualities. That is, it lets a particular amount of heat conduct through the ice, whereas snow is a great insulator and really halts almost much more substantially that conduction of heat. And so it actually allows sea ice to even grow naturally at the base more. So not only do you gain the growth or the thickening from the amount that you flood, but you get this enhancement of the natural process of sea ice thickening, which was what we've actually slowed down.
One kind of counterintuitive thing there is that the insulating effect of snow is bad here because it's stopping the ice from freezing, right? That's
kind of, yeah. It the sea ice itself is also an insulator, but the snow is just an exceptional insulator, and so that tapping of snow on top kind of slows down the growth of sea ice. And so if we can change it into ice itself, we accelerate the amount of growth and ultimately thicken the sea ice. So it's really just utilizing a natural process. Sea ice naturally floods when the snow is really deep and pushes the snow ice interface below the sea level. So we have this natural analog. We're just increasing what occurs naturally through an intervention. Now,
but scaling this up would be challenging.
Yes, and that's not really my area. I'm not an engineer who's thinking about the pumping challenge there. Instead, I'm thinking about the sea ice physics. And from my perspective, I think the physics is pretty clear and in hand. But the beads is another proposal. And I think what they didn't mention in that paper is the group that proposed it has taken it offline and said, we're not comfortable with this because it has this problem with being toxic to marine biota, like the phytoplankton. Sorry, it's actually the zooplankton consumes it and confuses it for its natural food source.
And just to clarify, these are these sort of glass
Glass beads.
bubbles. Glass,
They're
yeah.
beads. I
Okay.
mean, they look like sand. They're so small. And so they look very reflective. The other part of that was colleagues of mine showed that it's also more absorbing than was originally thought. So it really only could be effective on very thin, dark sea ice compared to snow. Like you wouldn't want to add it to snow. You wouldn't want to add it to very thick ice. So it had a kind of limited use, and then it was then shown to be toxic. So I think it was kind of, in my opinion, a little misleading to bundle those together when the group that proposed it has already put the brakes on, right? So these are two really different approaches, and I don't think they should be grouped together.
Yeah. So, John, I mean, they covered 5 of the ideas and there's 61 of them. And one that kind of raised my eyebrow the most was their analysis of stratospheric aerosol injection. I wrote a piece highlighting some of the issues, and there's a more technical one coming. But how did their summary of the science on SAI compare to your understanding of its effects at the poles?
I think it was not very even-handed. It's very clear that the majority of studies show that compared with the greenhouse gas consequences, if we continue along IPCC pathways, doing SRM will end up with a more equitable world. There will be a much healthier cryosphere, and there will be far fewer mortality rates compared with not doing SRM. I was one of the reviewers of Seagate, and I suggested several articles that should be cited, and they refused to cite them, which again, to me, doesn't show that they were genuinely open and trying to be comprehensive in their literature survey.
Well, because they do say, they basically conclude that it would be ineffective at cooling the poles. And they stress that there's no sun in winter, and therefore it wouldn't do anything in winter and would actually be harmful. Did you have a thoughts on that?
That's simply untrue. When we've done simulations of the impact on the Greenland ice sheet, for example, we find that one of the largest effects is during winter because there is more infrared radiation able to escape because the atmosphere is drier and water vapor absorbs a lot of the outgoing radiation that is cooling the surface. So in fact, Greenland would cool, the ocean surrounding Greenland would also have more sea ice, which would generally tend to favor increased mass balance for the ice sheet.
Yeah, and I guess this piece got quite a lot of coverage in the media, and it seemed to. I mean, I think with this piece and perhaps with the non-use agreement, you might be forgiven if you're an outsider for thinking that sort of a scientific consensus was developing around this topic. What's your reaction to that?
We ran surveys in the glaciology community and in the wider Arctic research community. And we are writing these up, but I can tell you, for example, one of the questions was a little bit like you have here. But we said, if as a scientist, if you were approached by someone wanting to do a project, would you welcome it? Would you ignore it? Would you actively work against it? About 10% of the respondents said they would actively work against it. Something like 2/3 of the respondents said they would welcome it. The rest would tend to ignore it. Obviously, that's a very crude, broad brush approach, but I think it does reflect my own personal reactions or interactions with the communities at meetings, that a lot of people want to keep their heads down because it's a controversial topic, but they are very glad that somebody is looking at this.
Yeah, Julius, how do you think, and how do people in the Sami community think about the sort of the tensions here? Because there seems to be quite a fraught issue that we're dealing with here.
Yeah, it's oh, I'm muted. Great. Yeah,
Oh,
no,
you're good.
yeah, no, there's a series of challenges that we do face. Yeah, and I guess not only within the field of geoengineering research proposals, but I think that's also it's also an issue in the overall Arctic research sphere, actually. So, yeah, so I'll try to outline them briefly. So first, Arctic indigenous people often do feel too often excluded from the design of this project, and are often experience that they are approached only after the projects have already been designed, funded, or even planned to launch. So yeah, it's a pretty unfortunate thing that leaves little space for shaping or the community's priorities or concerns, addressing their concerns in the research projects, and also having a due process in accordance with the free, prior, and informed consent that would allow there to be a process that would look into, okay, how should this project be pulled off, or should it be done in the first place? There's also another problem, and this is a bigger thing within climate, very relevant to climate interventions too, is that so with Arctic research on interventions, there are many projects and research that have a very, I guess, paternalistic and colonial sort of relationship or approach to doing research in the Arctic. So, for example, one project, I think that was the glass beads ones that you mentioned earlier, Cecilia. So that in that project, it described as the further work in Greenland as being that Greenland was having a humanitarian needs for outside interventions. So there's a big issue with that language in that it implies that people outside the Arctic researching this know what's best, for instance, the Inuit, while disregarding their knowledge, values, or concerns on how it might impact them. So it's there's still a big road there to go, and yeah.
And so just to cut in here, sorry, do you think, I mean, you mentioned the U-Arctic Interventions Project. I guess does that have, obviously that isn't it isn't doing the field work, it isn't out there doing stuff, but is that the kind of process that you'd like to see more of, that kind of where indigenous communities are more involved?
Yeah, so the project that we're doing is more of a broad assessment of the interventions, but wherever it's relevant, it would be great to have the indigenous peoples that are affected or in the regions of the wherever the interventions is going to take place. I mean, there's so many different kinds, but it depends on the project, but that they would be more involved from the start on and have a say in the project or the research done there. Excellent. Or even the launch. So
well, I'm conscious of the time, so I might hand over to Mark now to get questions from the audience, because I'm sure you've all got some interesting questions for our panel.
Sure, there's quite a few, some about governance, some about the science. There's also been a fairly healthy back and forth with some, but we're going to focus on the questions here to the panelists, if that's okay. Perhaps I'll start with this governance related one, and perhaps I could address that to Julius to begin with, and John as well. I think it pertains to the work you were talking about, Julius. Who or what organization would have moral authority, and this is from Doug Grant, would have moral authority and credibility for creating a strategic plan for research, testing, and potential deployment of plausible Arctic interventions? Likewise, who could endorse and advance such a plan to decision makers, whoever that may be, whether in the Arctic Council, the G7, the G20, or the COP? Thank you.
Yeah, that's a big question, and an excellent one is probably the million trillion-dollar question, I guess. No, but I think I mean, the Arctic Council was mentioned there. I think that would be an excellent body to start raising that question, and would have a set of the people who would yeah, be able to govern that sort of thing. I guess the discussion has to be started there, and it is there are cogs moving right now within the council on yeah, putting climate interventions as a question to, in for instance, one of the working groups named Arctic monitoring and yeah, yeah, Arctic monitoring and assessment program. So yeah.
Thanks.
I
John,
think
do
that,
you have anything to add to that? And perhaps
yeah, I
Cecilia
mean,
after as well.
there's an enormous difference between doing trials, which is assessing if a method works, and deploying it at some point after those trials have been done. Clearly, trials tend to be small scale, and you must, and it's only sensible to work with the local communities, exactly as is going on in Cambridge Bay with sea ice thickening. You must have the absolute cooperation, not merely the consent, I would say, of the local community. It's never going to work without their expert local knowledge and enthusiastic support, I would actually say. And if you envisage a roadmap that might lead to deployment, there will be many such trials and finding of appropriate ways, or finding of the red flags that mean that that is a dead end and we don't pursue that intervention further. But at the first stage, which is where we are, it is the local communities that have the priority rights, and they must be the people at the first step.
Is there something you would like to add to that, Cecilia? Or alternatively, I've got another question for you, but up to
I
you.
think they answered it really well, so I'll take the alternative.
Great, great. Well, one of them is yes, one of them. Let me start with the tipping point. Well, what impact would the loss of Arctic sea ice have on global ocean currents, such as the Atlantic overturning circulation?
Well, sea ice, as I was saying, it insulates the ocean from losing its heat to the atmosphere, which is one of the main drivers for creating the dense water in the North Atlantic. The other is, of course, the loss of fresh water itself. So the evaporation makes it denser by increasing the salinity. So more salt or colder, both cause it to sink. And it's already pretty saline because it's traveled up from the tropics. So the main thing that's really happening in the northern North Atlantic is the loss of heat. So actually losing sea ice may enhance the Atlantic meridional overturning circulation because it could lose more heat. That said, it's why did the sea ice disappear, right? And it disappears because it gets warmer. So the atmosphere itself is less drawing the heat out, when the climate warms, which is the bigger reason why the AMOC slows down in all of our climate projections. It's not because of the heat.
And perhaps, this is, I guess, goes one step further, but if you could take this on from Jake Schwartz, how can we look at the question of how much time we have before we reach tipping points, such as permafrost melting or ice sheet collapse, before only climate intervention could save them, with the save in quote marks?
But I think the question is like, how long do we have to deploy these kinds of techniques in order to avoid a tipping point?
Yeah, how would we consider the amount of time left before climate intervention would be essential?
Right. Well, I think that's a hard question because these kinds of thresholds are always tricky to quantify, and when we've crossed them. But at least with regard to the sea ice, I did look at this question, and I think it's a much more manageable question because sea ice is just one component of the climate system. So when I did simulations, we asked, well, when should we start thickening the sea ice in order to save the sea ice from disappearing in summer? And unfortunately, it was rather soon, like within the next decade. And you have to thicken ice that's already present. If it's gone, it's too late. And so we had to start immediately, which really presents a challenge because these governance issues are so tricky. To do this at scale, it will take time. And so I think it's a race, unfortunately. Yeah.
Thank
We
you.
don't have a lot of luxury of time here.
Thank you. John, I've got one for you, which I think you'd be able to answer, but also maybe Pete would want to jump in on this one as well. From Tom Harris, can you discuss the risks of termination shock, especially with stratospheric aerosol injection? We could be locked into putting more and more up forever to avoid a future very rapid warming that could be worse than the gradual effects that could be adapted for. Response to
Well,
that?
yeah, I mean, you should never go into a deployment without an exit strategy. That's the first thing. It clearly is something with strict limits. You cannot simply keep putting more and more stuff in. It gets less effective per ton as you increase its concentration there in the atmosphere. So you have to go in there without thinking, oh, this is an alternative to decarbonization. It's absolutely not. It's about preventing the worst impacts that carbon already in the atmosphere is doing. But in the meantime, you should be certainly not emitting any more carbon at that point, and you should be trying to suck it out as fast as possible so that you can exit as gracefully as possible from that intervention strategy at some point down the line. But there needs to be a gradual drop off. You can always envisage scenarios, global conflicts or whatever, where somebody just turns it off. You know, there are a million ways of doing things wrong. There's the golden path of doing it right. And we're looking for that golden path.
Well, and maybe I could just add a little in there. I think, presuming we're under a scenario where, emissions have been constrained and plans are in place to remove carbon dioxide from the atmosphere, we'd still have and we would say cooling 0.5 degree or 1 degree Celsius with SRM. We would be committed for some time because if that 1 Celsius of warming is being offset by stratospheric aerosol injection and that were to end, the cooling effect disappears or the particles disappear within a year or two and the warming would come back much more quickly than it would have. However, there are many, many systems that if they were to suddenly stop would imperil us all. International trade, electricity, and many of these systems would imperil us in very short order. If international shipping all got shut down, countries would starve in weeks. So I think there's an element where this is a system that's actually got a bit more of a longer time scale than some of the things we depend on.
Brilliant.
But
Well, we've got quite a lot
long
of stuff
commitment.
on this on our website, so please check out SRM360 for that. I've got one more for John. This is from Tyler. Do we know what level of average global warming will cause sea ice thickening interventions to not work?
Yeah, that is a very good question. I mean, as Cecilia already said, you can only thicken ice that's already there. So once it's gone, you're screwed on that approach. And so we're looking within fairly short order at probably less than a degree above where we are now.
Okay, thank you. I got one final question now for this section. We could address a couple more at the end. Very quickly, Julius, I just wanted to read out Michael Diamond's question. Perhaps you've answered some of this already. For Indigenous and local Arctic communities, how much interest is there in involvement with modeling studies? What is the best way to incorporate community input for smaller computer-based studies, if that is desirable, as opposed to, for outdoor work? Thank you.
Yeah, interesting question, and I think modeling is a very safe field in the sense that there's no outside engineering or structures needed for that. But I think it's already been done to some degree in Sápmi, and I mentioned before the rain on snow events where I think that's something that's been simulated, and that there has been done some studies that have been useful to reindeer herders in that field. So
thank you. So I'm mindful that we're reaching the end of the hour. So we will have a couple more minutes at the end. Thank you everybody for staying so far. If you can find a moment at the end, please do complete our post-event survey. You can also sign up for our newsletter, follow us on social media. And if you have any more questions, we have a handy Ask a Question box on the front page of our website. So make use. Pete, I'll perhaps hand over to you for a wrap up.
Yeah, so our last minute here, we're going to revisit our initial poll and see if there's been any shift in the answers. So if Kerry could flash that up again. Here we are. So same question again. Further research into solar geoengineering and other polar interventions is a waste of resources, not a priority, should be given higher priority, or urgently needed. If you could just quickly fill that in again, and we'll see if there's been any shift. I think we've lost a few participants by now, so the absolute numbers might not quite tally up, but maybe we'll have seen a shift in the ratio. Let's see. Kerry, are you able to? Oh, there we go. Let's see if we can get the answers up. Oh my goodness, look at that. We've shifted. Urgently needed is now a higher priority. We've got no waste of resources and a little less, not really a priority. Well, there we go. The impact of our discussion. Great. And I think we have one last poll, which is to ask which topics or questions you'd like to see us cover in future discussions. So if we could flash that up very quickly. And then, as Mark's been saying before, we've got a little extra time after the end of this recording, which will close just shortly. So yeah, if you just want to quickly type in, is there a topic, question, issue you'd like to see us address in a future panel? Possibly if a suggestion of a name of someone. Bang that in there. We'll collect these up. We won't review them right now, but we'll collect them up and consider your suggestions. Well, thanks for those who joined this discussion. And again, if you want to hang around for another few minutes to hear another few more questions, you can do. I'm not sure if Kerry's going to now end the session. But yeah, thanks for those who joined.
Brilliant. Thank you. Okay, let me just go through the last couple of questions left in the chat. We've got one from Gregory Slater. Says, it's a permafrost. What about drilling core samples to monitor and map the evolving state of permafrost? Would anyone like to take that? John?
Well, yeah, they're actually probably the most active researchers in permafrost are in Russia. And of course, we've lost a lot of that since the Ukraine war. And therefore, we know less than we should do about what's actually going on there. But yeah, there are probably in the order of hundreds of boreholes across the permafrost. So yeah, that people are doing that study.
Thank you. I've got a question from Arthur Dahl. Do plankton below the sea ice depend on light filtering through, and how will they be negatively impacted, presumably by climate change or interventions?
Yes, they are, and they need light. So thinner sea ice tend to have greater ecosystem, dynamics going underneath. There's more populations of zooplankton and phytoplankton, but yeah. So we would expect there to be some point when, with loss of sea ice, or thinning of the sea ice, that these populations to grow. But then, of course, there's a point where there's no sea ice and they can't survive anymore. And the populations will shift because there are types that are ice adapted and types that are not. And definitely thickening the sea ice will impact those populations.
Thank you.
Yeah.
I've also got a question from Gregory Slater. Is there a particularly good site that you recommend for seasonal Arctic ice coverage and depth over years?
Well, maybe I could just pipe in here. We looked at the National Snow and Ice Data Center. Is that right? That's where we got the data for our charts. I think some of the other centers do that kind of thing too. I'm not sure if Cecilia, you want to add something.
So the question was website. Yes, exactly. That's where I would look. There's also thickness measurements there that are readily available. And they have a nice mapping tool that you can make figures yourself with. You don't just have to download the data and process it. It's great.
But
great
I think
resource.
that the key point though is you find somewhere where there is where there's a market for that kind of an intervention, where people want it to get done. I think that's the most crucial thing. And that's why they've gone to Cambridge Bay and are doing it there, because the local people would very much like to have more sea ice and more stable sea ice for their everyday life activities.
Gregory asked, you've spoken about losing contact with Russian polar research. Is the West actively shunning the Russians as punishment for being Russians? Interesting way of putting
No.
it, but
And in fact, of course, many people have personal relationships that they've developed over multi-generations of working in Russia, and those haven't been shut down, but certainly official I'm in Finland, and some people have even been fired for taking part in Russian activities. So you have to be very careful. In a way, it's harder than it was during the Cold War. There's more complete shut off. But I know Julius maintains contacts with his counterparts.
It's complicated on our end too. Well, we're one people across 4 countries, and one of them is Russia. So, because of issues with, for instance, project funding that limits, who we can work with, and given that EU has taken part in sanctioning, Russia in the sense that we can't collaborate with the people there. It's I think that's more of the It's more of a structural thing that inhibits that sort of collaboration between the West and our Russian colleagues. Yeah.
If I might jump in, Mark, I mean,
Oh,
I guess the question I had that I didn't have time to ask, I guess, kind of on a similar theme of kind of tensions between parties. What are the hopes, Cecilia, of us getting to a scientific consensus on these kind of controversial topics, like we did for climate change, but for these solar geoengineering and polar interventions? Is there much hope of that? What's a path forward that could get us there?
Well, I can speak to the ice thickening, which is what I think a lot about. And I think, it's a matter of how we want to utilize it. If we want to do, I think, what is being requested by communities driven by local peoples, like in Cambridge Bay, I don't think the world would have too much objection to that. But how do we come to consensus? I mean, I think it just takes a lot of conversations. And I think it's also, what we want to do is let everyone be heard, but I don't think we're going to come to 100% consensus. And, we have to decide what's good enough. And I don't know what that is, but, there are people who think about this, professionals, and I would ask them.
I'll turn that over to Jug. I guess the thinking of things like stratospheric aerosol injection. I mean, I think in a sense there is a core science that could be agreed on, and then there is a political layer and ethical layer that we're bound to disagree on. What are the hopes of getting the science together on that in a way that's coherent, given that kind of political tension around the topic?
Well, I don't really think the science is the problem. It's the psychological aspects of it. And yeah, as Cecilia said, there are experts that do that. People follow their hearts, they don't follow their heads exactly. So I think, I don't know, I think it's one of these things that humans are not very good at doing. We're very good at dealing with, there's a lion at the door of the cave or somewhere like that. But we're very bad at, this is some long-term thing that's going to affect my children. What do I need to do now to avoid it? And I don't know any way around that except to just have time. And the problem is we may not have the time.
Well, I guess one final question, I suppose, comment, the last one from Robert Tulip. Is it not astounding that the safeguarding paper, I assume he's referring to the paper we were discussing earlier, fails to see that cutting emissions as a climate strategy is too small, slow, difficult, and contested to possibly reverse the fall in planetary albedo from loss of ice and clouds? Question mark. Any last thoughts on that? Oh, I think.
Yeah. Well, I guess we already commented that, it looks like the emissions cuts are not happening fast enough and the impacts are coming at us quick.
I think we're done then. We've answered the questions. Thank you so much, everyone.
Cool. Well, thanks for joining us. And thanks to the panel, Celia, Julius, and John.
Yeah, thanks for inviting us.
Happy to be here.
Fab. There we go.